Hello, welcome. Let's try to solve another Leetcode problem, 224 basic calculator. So for this problem, we are giving a string as representing a valid expression. So we're going to implement a basic calculator to evaluate, and we're going to return the result of the evaluation. So yeah, note we can use some method. So for example, eval to calculate the mathematical expressions, but that is not okay for this problem. We have to use some other method. So for example, we can just try to return something like eval with s, and we can pass, of course, for some testing cases, but we cannot pass for all of them. So this is specially designed for that, because we cannot nest so many processes. So it didn't work. And definitely, even it works, we cannot use this eval. Normally, if we know the problem is about something called calculator, it means the mathematical expressions we need to calculate. Basically, it's going to be a stack problem. So while we are solving a stack problem, normally it's going to be hard, and the hardest part is the calculator, and the calculator problems will always be the hardest part of the stack problem. So for solving this problem, normally we're gonna find an easy pattern, and then we're gonna gradually find the hard pattern to solve it. So the easy pattern is, what about if there's no processes? How are we gonna deal with this problem? So for example, for the first example, there's no processes, and the second example, there's no processes. So we just ignore the third example. Even for this third example, if there's no processes, we can still get the right result, because if we just remove all the processes, it is still okay. And then we're gonna just add the processes to check if we can just add a left processes and left all the right processes to finish the problem. So if we don't have processes, so the calculations would be easier. Normally we don't need a stack. So we're gonna use a result to record our final result. So from the beginning, we're gonna set it to 0. And we're going to use a current variable, so it's going to be the current number. We're going to set it as 0, and we're going to use a sign, so it's going to be the positive and negative side. Basically, it's plus and minus sign. Because in our problem there's no multiplication and there's no division, so the calculations would be easier normally. So we're going to prepare a sign from the beginning. It's going to be equal to 1. We just mentioned there's no processes. So excuse me, sorry. So now let's just try to check the first number. So for example, we are checking this first number, it is 1. So for example, even the first number can be 1 too, and this is easy to calculate. We just use some mathematical calculations to calculate like 12 or 1, it is okay. So currently for this example, we have a number 1. So if we come across a number 1, we're going to record the final result. So it's going to be result plus equal to the current. So this is 1 is the current times the sign. So sign is 1. 1 times 1, it is 1. So currently this result is going to be updated to 1. Because we come across this 1. Now we have a plus sign. So if we have this plus sign, we're going to update the sign variable. So it's going to be 1. Because it is a plus sign, so it's going to be 1. If it is a minus sign, it's going to be a negative 1. So we're going to set a positive 1 as the positive sign and the negative 1 as the negative sign. Now currently this sign is going to be 1, and now we come across another number. So if we find another number, we're going to update it to our result. So the result is 1. So it's going to be like 1 plus the current number, it is 1, times the sign, it is 1. So 1 plus 1 is going to be 2. So this is going to be the final result. And similarly, for example, 2, like 2 minus 1, we're going to get a 1. And then we find a plus sign, so this is going to be the sign, and 2 is going to be the number. So 2 times 1 is going to be 2. 1 plus 2 is going to be 3. Now let's just write the easy one. And after finishing the easy one, we're gonna finish in the hard one. So for the easy one is we're gonna prepare a result and current, and we're gonna prepare a sign. So it's gonna be 0, 0, and 1, because for the sign it's gonna be a positive sign from the beginning. We set it, so it's gonna be a 1. Now we're gonna check the characters one by one. So if this character is a digit, So this means, yeah, we just need to accumulate the number. So how can we accumulate that? So current gonna equal to current times 10 plus the integer of this character. Now we've updated the current. So what's gonna be the next step? So the next step is that we're gonna check the next character. So if this next character is inside, so for example plus and minus, yeah. So if the next character is a sign character, basically it is a positive or negative sign. So what are we gonna do? Yeah. For example, this is a 1. This is our current, and now we have this sign. Yeah. So we're gonna record our result first. So result gonna plus equal to the current times the sign. So basically the result currently it is 1. We're gonna record we're gonna record the result, and we're gonna set the current to 0, and we're gonna prepare the sign to 1. So if character equal to the positive sign, otherwise we're gonna set the sign as negative 1. Yeah. Finally, we're gonna return, and the answer is gonna be the result. But before that, what about the last number? So for example, the last number is 1. Yeah. So this one is a digit, and we're gonna update the current. So the current is gonna be 1. Yeah. So 0 times 10 plus 1. So the current is gonna be 1. And we finish the for loop. So what about the last one? We need to put this last one to the final result. So this means from here, out of the for loop, if we go out of the for loop, we still need to have this result gonna plus equal to current times this sign. Yeah, so this is gonna be the final result. Yeah. Now let me just run it. Now as you can see, it works. At least it works for example 1 and 2 because there's no parentheses, and for example 3, even there is a parentheses, but it is okay. Yeah, we can just remove the parentheses because the final result gonna be the same. But for another example, for example, yeah, for this one minus parentheses inside this negative 2 and parentheses, it didn't work. Yeah, because the final result gonna be 3 and our result gonna be negative 1. Yeah, so the current code didn't work for the parentheses. So this means we need to analyze how we're gonna deal with the parentheses. So this is gonna be a difficult part. So for solving the parentheses, so for example, currently we have a value like, currently we have a value of 1 and a positive sign. Yeah, so this is okay. Yeah, so for example, for this example from the beginning, we have a parentheses. So what are we gonna do? Yeah, and then we're gonna have this 1 plus sign. What are we gonna do? Yeah, so basically we need a stack to store all the current calculated value. So inside of the stack, it's gonna be a result and a sign. Yeah, so inside of the stack, it's gonna be those two variables. We're gonna store a result and a sign. So this is the previous calculated result. Basically, it is this one. And then we're gonna use another result. So it is. Let me just put it like this way. Yeah, so it is the result and sign inside of the stack. And then we find another parentheses. So we're gonna just reset the result and sign to calculate this result. So inside of the stack, there's gonna be a result. This is a 1, and this is a positive sign. Yeah, and then we find another left parenthesis, and we just need to calculate the result inside. Yeah, so basically this result and sign, it's gonna be 4 plus 5 plus 2. It's gonna be 11. Yeah. Now what are we gonna do? We just need to, so for example, if we find a right parenthesis, we're gonna get 11. So if we find another parenthesis, we just use this 11 to get the final result. So we're gonna first pop it out. So this is a positive 1. 11 times 1, it is 11, and then plus 1, it's gonna be 12. Yeah. Now, let's just imagine there's no negative 3. Our calculation is just like 1 plus 4 plus 5 plus 2. Yeah, and we're gonna have this kind of a parenthesis. Yeah. So if we have a left parenthesis, so inside inside the stack, we need to store the result and the sign. So what is the current result? It is 1. And what is the sign? It's a positive sign. Actually, this is a number. This is a number 1. Yeah. So this is the first step. If we find this left parenthesis. So currently, if we find this left parenthesis, we're gonna store a value of this 1 and a positive sign. Yeah. But from the beginning, for this left parenthesis, there's nothing inside. So we're gonna store the result as 0 and the sign just as this positive 1. Yeah, because that doesn't matter. Yeah, because this positive 1 is just a sign, and the result gonna be 0 and positive sign. But currently, let's just consider this left sign, this left parenthesis. If we find this left parenthesis, what's gonna be inside the stack? Yeah, let's just make it simpler, and I want to just remove this parenthesis and this parenthesis. Let's just make it simple because this is easier to analyze. After that, we're gonna finish the algorithm. Yeah. So currently we have this 1, and we put this 1 inside of the stack, and we find this positive sign, and we're gonna put the positive sign inside of the inside of the stack as well. Yeah, because for here, so from the beginning, there's no left parenthesis, but we're gonna update the result, so the result gonna be 1, and the sign gonna be 1, gonna be this positive sign. But now we find this left parenthesis is here. We need to put the result and the stack and the sign inside the stack, because later on we're gonna use it. Because basically this means, oh, this is from the left side. This is from the left side. I need to store it, and then I just need to get this 11 value, and then I can finish all my calculations. So basically the parentheses with the plus and minus side is going to be the calculation from the left to the right. Yeah, so this is exactly like what we are calculating. Now we find this left parenthesis and we put it inside, and we just need to reset the result, because currently this result is going to be used for the next calculation. So for this result, we're going to set it to 0, and for the sign, if we find a left parenthesis, definitely we're going to set the sign as 1. Now let's just ignore this stack at the moment, because currently it is just the numbers plus 5 plus 2. We just ignore the parentheses. It is just like the calculation before, like here. So this means we can finish the calculation like 4 plus 5 plus 2. It's gonna be 11, right? Yeah. So this 11 gonna be the result. So the result gonna be updated to 11, and because there's no negative sign, so the sign gonna be 1. So for the last step, we find the right parentheses. So if we find the right parentheses, basically what we're gonna do? We're gonna finish the first step. So this means we're gonna update the current result. It's gonna be this 11 times this sign. Basically, it's gonna be 11. And then we're gonna set the current number to 0, because it may be used for the next calculation. Maybe after this parenthesis, there's some value like plus 2 plus 1. Yeah, so we're gonna set the current to 0. Yeah. Now we have our result. It is 11, but we didn't consider this 1 and this plus sign. So this means we're gonna first pop out this plus sign. So it's gonna be 11 times 1. It's gonna be 11, and then we're gonna pop out this 1. It means 11 plus a 1. So it's gonna be 12. So this 12 gonna be our final result. Yeah. So this calculation, it is 12. Yeah. Now let's just finish this kind of calculation. Yeah, basically I don't think there's any easy way to solve the calculator problem. It is always hard, but from the beginning we might consider, what about without parentheses? We just consider it like this way, and then we're gonna build it up from the ground, from the basics, and maybe this way we can solve it easily. Now if we find it is a left parenthesis, so what are we gonna do? As I said before, normally we need to put the result and the sign inside the stack. Yeah, and then we're gonna reset the result and the sign to be 0 and the sign to be 1. So this is what if we find the left parentheses. Yeah. Now, if we find a right parentheses, what are we gonna do? Yeah, definitely, as I explained earlier, we're gonna update the result first. It's gonna be the current times the sign. We're gonna update the result, and we're gonna set the current to 0. Maybe it can be used for the next calculation. And then we're gonna pop it out, and it's gonna be result times equal, because the first pop out it's gonna be a sign. Yeah, and the second pop out, so the stack dot pop is gonna be a sign, and the second pop out is gonna be a value. So it's gonna be the stack dot pop. It's gonna be a value. Yeah. So let me just explain a little bit about before, because we cannot say it, but let's just use this example. 4, 5, and 2. Yeah. So currently, as I explained earlier, so inside of the stack it's gonna be a 1 and a positive sign. Yeah. Now we're gonna accumulate. If we find a left parenthesis, we're gonna accumulate those values. So basically, the stack gonna put this inside. This is gonna be the first step, and then we're gonna set the result to 0 and sign to 1, and then we're gonna start the calculation. So if we find a 4, oh, so this is the 4. The current is 4. Now if we find a plus sign, so we're gonna update the result, which is gonna be 4 current times the sign, and we're gonna set the sign to positive to 1, and the current gonna be 0. Yeah. Now we find a 5. We're gonna update the result. It's gonna be 4 plus 5. It's gonna be 9, and the current is gonna be 0, and the sign is gonna be 1. Now we find a 2. We're gonna update the result, so the result is gonna be 11, and the current gonna be 0, and the sign is gonna be 1. Yeah. Now everything is okay. Inside of the stack, it is still this 1 and positive sign. But while we find this closing parenthesis, the right parenthesis, we need to update the result. So the result is gonna be this 11 times the sign. So for this parenthesis, yeah. So for the last sign, as we set it, it's gonna be from here. Yeah, it's gonna be 1 last sign. So yeah, let me check the last sign. Yeah, so the last sign is here. So the last sign is here. It is 1. So if we find this closing parenthesis, we're gonna update the result. It's gonna be 11, and we're gonna set the current to 0, and then we're gonna pop out this positive sign. So it means 11 times 1 is gonna be 11, and then we're gonna pop out this one, the number. So plus 1 is gonna be 12. Yeah. But currently, as we set this current to 0, so this means if the final result is a right parenthesis, basically, yeah, for this calculation, it is a 0, because current is 0 times this sign, it's gonna be 0. So result plus 0, it's gonna be, yeah, the result as before. Now let me try to submit it to check if it works. Oh, I didn't define the stack. Let me just define the stack. It's gonna be an empty array. Now let me just try to check. As you can see, now it works. Now let me just submit it to prove that it can pass. As you can see, it's pretty fast, and it passes for all testing cases. And the time complexity is ON, because definitely we are using a stack. Yeah, as you can see, the length of the string is 10 to the power of 5. This means basically we're going to use ON to solve the problem. Yeah, and such kind of operations, it is just told you which is invalid and which is valid. Yeah, I think that's all for this problem. Thank you for watching. See you next time.